Welcome to the Maxpreneurs Podcast, the podcast about the stories of Mexican tech startup founders who are building world-class, fast-growing companies and having a positive impact at a large scale. My name is Sergio Chavez. I'm a Mexican based in Germany, a tech startup founder, executive, and mentor, and your host. Today we welcome back Dylan Roman. Dylan, together with Maximilian Wolf and Erube Flores, are the founders of NIU NIU, an e-waste recycling startup based in Mexico City. NIU NIU is the operating system of e-waste. Through the use of AI, NIU NIU maximizes critical mineral recovery like lithium, cobalt, and rare earths, while minimizing the environmental and social impact of e-waste management. It also accelerates the recovery of essential resources from post-consumption and post-industrial electronic scrap. In addition, via image recognition and through its platform, NIU NIU classifies and distributes e-waste, which is then transformed into key materials needed for electronic vehicles production and energy transition. Dylan is CEO, responsible for the company overall, with a special focus on go-to-market and fundraising. Maximilian is CFO, responsible for financial and administrative processes between all entities. Finally, Erube is CTO and is focused on technology development and operations, working directly on-site at e-waste recycling sites. I hope you enjoy. Support for this episode comes from Partnership Leaders, the leading community of partnership professionals and executives in SaaS and tech, with over 1,500 members globally. We're living the decade of the ecosystem, and every CEO needs to become a partnership leader. Just take a look at the top companies in the world today, like Microsoft, Google, and Apple. They have all become platform companies, and partnership executives in IT have been the ones leading these transformations. Partnership Leaders brings these executives together and is building a playbook to enable CEOs and business leaders across industries to transform their organizations into platform companies. If you're a tech startup founder, Partnership Leaders is the place for you to learn how to leverage partnerships to take your business to the next level. I'm a member of PL and co-host of the Germany chapter and have seen firsthand the richness and value of this incredible community. Visit partnershipleaders.com to learn more and to apply to become a member. Make sure to mention in your application that Maxpreneurs referred you so you can receive a special price if your application is accepted. Hello, Dylan. Welcome back.
Hello, Sergio. Thank you very much for the invitation.
And thank you for being here again. So, Dylan, please tell us, what is NIU NIU?
Well, NIU NIU started as an operating system for connecting the different actors in the e-waste sector, which means all large e-waste generators, let's say the electronic OEMs, automotive, aerospace, as well as their tier 1 and tier 2 suppliers that generate practically e-waste from their production. They are the largest clients that have to dispose of their e-waste in a correct manner. And on the other side, we have large consumers like universities, banks, and of course, civil society that generate post-consumption e-waste, and that it has to be also disposed correctly. And we connect practically those e-waste generators with disassembling plants first, and then with the refineries that can extract practically the critical minerals that are contained in the components, such as PCBs and batteries.
And by operating system, what exactly do you mean by operating system?
An operating system connects the users and makes the relations between them more efficient. So that's practically where we took the idea from. And in, let's say, more startup-y terms, it's becoming something similar as a marketplace.
So where you're connecting the main actors related to e-waste. So you were mentioning the OEMs, so the manufacturers, from the devices, from the different electronics, then the consumers, and then you were mentioning the ones that are disassembling the parts. And then what happens with that disassembling of the parts? Are they being then reused? There's some waste being generated. Like, what happens via the connection of these different actors?
We did some experiments for reuse before doing the recycling, but we identified that the equipments that we're getting mainly from the civil society are already quite obsolete. To repair them or refurbish them and then to try to sell them, the cost of sales is very, very high. That's why it doesn't make sense to refurbish or reuse them. In the case of large e-waste generators, they often want their data completely erased. And the easiest way is to practically destroy the equipment. So that's how we ensure that their data will be safe. What we do practically with the equipment, or what the disassembling plants do, is they dismantle them into mainly three categories, which are plastics, which is more or less one third, metals, which is also around one third, and the other 40% is waste, which cannot be recycled, and components such as batteries and printed circuit boards.
And then what happens with that plastic? What happens with that metals? How are they being reutilized afterwards?
Let's say the difficulty of e-waste recycling is that materials are very heterogeneous. Plastics are often not only one type of plastic, like in a bottle, but it can be polyester with one fiber, or different combinations of plastics. So we have to identify them and classify them in order to be able to sell them so that they can be recycled. And the same is practically with metals. We classify them according, practically to their properties. For example, copper, aluminum, and ferrum, or what we call in Mexico chatarra, are the main categories, but they have also subcategories depending on their quality.
And how big is this problem? So you're connecting the different actors. We're talking about basically dismantling these parts, the generation of e-waste. How big is this issue overall? And is this a global issue? Is this a regional issue? Like, how big is this thing with e-waste that you guys are tackling?
Worldwide, we produce around 56 billion tons of e-waste. So it's more or less 8 to 10 kilos per person, depending on the country. And there's only less than 13% being recycled today. This would make 87% of the materials that are used for electronics practically part of a linear economy, in which once the equipments are come to their end of life, they are disposed in a manner that practically doesn't allow for the recovery of the materials that are inside of it, mainly ending up in landfills.
And this means like those big piles that you sometimes see, that just e-waste getting accumulated and basically getting rusted, no longer being used, contaminating fields. But also e-waste is quite sensible, no? So in terms of the environmental impact, that, let's say, just leaving some batteries out there, so just leaving some computers out there, it also has a significant impact. Could you elaborate a little bit more of why also the treatment of e-waste is so important? Like, just piling them somewhere is also a big thing to tackle?
Yes, I mean, it has the best and the worst, right? So it contains very small amounts of precious metals, which sometimes people think that they are easy to, like, okay, if I open my iPhone, I will find a gram of gold. It's not the case, unfortunately. And they contain also the most toxic, let's say, aspects. One of them, and that's how we practically started our project, are the flame retardants containing plastics. You probably have had your phone on your hand and it gets really hot. And in order for electronics to not pick fire, the plastics contain flame retardants that practically delay the moment in which they pick up fire based on the temperature. Those flame retardants are, or used to be, brome containing components, which are highly toxic. They were practically banned by the European Union in the ROHS directive, and they are regulated under the Stockholm and the Basel Convention. This is for transboundary movements of e-waste. So what happens in the countries is practically still not so regulated. And the problem with these flame retardants is that they are known as persistent organic pollutants, which means that they can travel very long distances and they accumulate organically in our bodies, in the fat practically. Once they accumulate, they can have a bunch of different consequences to the health of humans, but of course of animals as well. For example, cancer or dysfunctions at the neuronal level, as well as cognitive effects And in women also, they can have an impact on their when they're pregnant.
So that's also the rationale of why the proper treatment disposal of e-waste is so critical. But also, could you please share us okay, so it's a very complex problem, it's a big problem, but what's the big vision behind New New? Like what's that North Star? What would you guys like to achieve as a big long-term vision overall?
Mining has always been well, not always, but has very often been an example of the worst atrocities against humans, against nature, and as an industry is, let's say, not often seen as the standard, although there are, of course, many companies that are trying to do a change in this aspect. Still, where mining means extracting, or as miners use it, exploiting literally, right, the resources that we have in the planet to practically produce goods that we use in our homes and that we very often forget where they come from and under which conditions they were obtained. So our goal at New New is practically to create a clean and fair supply of critical minerals, which are already contained in the electronics, and that we create a supply of these materials, which is fair with the environment and with the people that work all along the chain.
By that, you mean also the fact of minimizing the exploitation of these minerals and actually reusing them as much as possible, I assume.
Exactly. By practically promoting a circular economy of these critical minerals, we are diminishing the necessity to extract them practically raw in primary materials.
And of course, this is a big mission, a big challenge that you guys are tackling. But please walk us through the traction that you've seen up to date. So, New New has already been in place for a few years. What's been that impact, those big achievements that you've reached so far?
I think the first was the consultancy project that we did for this international agency to identify the main problems of the circular economy, right? So over almost 2 years, we identified in a lot of detail which were the problems, the real problems that the dismantling plants in Mexico were having to promote the circular economy of electronics and or of of electronics practically, and testing different solutions to solve those problems. That was our first milestone, practically the product market fit of the, well, identifying the problem first and then creating solutions that could solve it, and then finding a market that would make it economically viable. That ended up practically in 2022. And June 2022, we decided to launch this company that practically solves those problems that we were identifying that were not being solved by the current industry, and where we could not build the capacities in the current state of the companies. So I think that would be a first milestone. It was a large implementation project, but practically with less skin on the game than doing it your own, right? That's where we decided to put our hands on practically, and we transitioned towards becoming a startup instead of a consultancy project. We did some accelerator programs with fundraisers in Berlin. Had a special mention there as we graduated. We then did the founding lab, which is also part of the Founder Institute, let's say, community in Palo Alto. Some of the KPIs that we have in terms of production, up to date, we have more than 20,000 students have been impacted by our environmental education programs that we do with high schools and universities, which practically helps us as a channel of awareness raising first, and of course of collection of e-waste with civil society, which is, let's say, the sector that's most forgotten by the recyclers. With that, we have processed more than 200 tons of electronic waste through our plants in Mexico. We have also identified more or less what is the environmental impact of it in terms of CO2 and plastic recycling, etc. The amounts of plastic that are contaminated, that have not reached again, let's say, the productions, or that have not been sent to landfills, because in those cases, like if you recycle contaminated plastics, it ends up again in sometimes Tupperware or the toys for the kids, right? That they immediately put into their mouths. So that's what we're trying to stop. And we have worked with different clients from the telecommunications industry, automotive industry, of course, the IT production, as well as automotive, I've already mentioned, who supply us practically with the waste, and we bring it to one of the two plants we are currently collaborating with in Mexico and in Guadalajara, so that we can dismantle them and then practically take them to the refineries. At the moment, we are in conversations with 35 different refineries, and we have agreements with 3 of them.
And these are refineries in Mexico, or these are refineries somewhere else?
No, they're all abroad. Yeah. There's currently no capacity for refining, or at least formal capacity for refining in Mexico.
But what's the major bottleneck for that? Or why are these refineries mainly abroad and not in Mexico?
I think there's an historic component to that. The main companies established in the 80s in Europe, mainly in Belgium and in Germany, and they were refining sites for traditional mining that identified, okay, e-waste is a stream that we could actually also refine, and that's more concentrated, but it's very heterogeneous, right? It's not like ore where you have maybe 1 or 2 different elements. Here you have 42 different elements that you can recover from electronic waste. As, let's say, the materials are very heterogeneous, they require many processes in order to recover practically the different streams of elements. And this can mainly be achieved through economy of scales. So processes that allow you through an amount of unitary processes and a lot of material to recover a significant amounts of each element. So it's partly economy of scales that requires a lot of investment in the case of printed circuit boards. And in the case of batteries, the tendency is new. Practically the 2 largest recycling plants were announced probably in the past 5 years, and each of them has collected more than 1 billion in investment. The one in Europe, 4 billion this year. This is just in one round of investment. You can imagine that not every country has the capacity to have this, investment power to build this kind of facilities.
So the barrier of entry to create one of those refineries is very high, and that's the reason why it's not so easy for a country to roll out a new refinery, and that's why it's more concentrated in specific countries, US, Germany, and so forth. So that's super interesting. So, and the fact that how you guys are connecting all of those dots. And also, there's, of course, an important technology component, no, in terms of AI, in terms of image recovery. Can you expand a little bit more about that technology that you guys have created as well?
Like in every waste stream, you require the most homogeneous streams that you can. For example, at home, you separate cardboard from plastics and from, let's say, the beer cans, right? So you have aluminum and then plastics and then paper. And the same is valid for electronic waste. The difference here is that it is, in the case of components, very difficult for the human eye to identify the value or the characteristics under which they should be categorized on. And what we created and what we are training is a model that can identify practically the precious metal content of each stream, so that the printed circuit boards can be, and other components can be separated, just as we do at home, based on their characteristics, so that the trading and, of course, the refining of these materials becomes easier.
Especially if you're moving tons of material back and forth, like you can of course do it with the human eye, but then you would require a huge team to do that. And also I would assume the possibilities of error or skipping things is significantly high. So it's only with technology that can scale that I would assume you can really process a significant amount of e-waste.
Yes, of course. It is not only the velocity in which humans can do that work, but the accuracy. We're very bad at identifying or, let's say, assessing different variables in a short period of time correctly. So this is a task that we're humans especially bad at. So this is why we identified, okay, this is a problem that could be solved with technology. And we tried it out in our MVP and it worked out pretty well. What we are building at the moment is probably step in the middle, which is based on data sets that are not available in the market. Eventually, we believe that the market will become a little bit more transparent. There's a huge opacity at the moment, and the data will be a little bit more available to other players as well. So by then, our technology has to be quite developed and spread out.
And now let's transition briefly to the team, because of course you're managing all these different stakeholders, you're creating the technology, you're basically creating these marketplace, this platform. And as far as I understand, it's not only you have also two co-founders. So how exactly, who's doing what, and how are you guys basically tackling all those different things that you're managing?
The three of us, well, it's practically Erube, who is more the hands and has a lot of knowledge on electronic waste at in an empirical way. Practically, he has been working with electronic waste for the past 15 years and has a lot of knowledge on how to dismantle it, how to classify the materials, how to guide also, like a group of people that work in our plants, etc., how to train them. Then there's Max, who is in Germany, and he's practically in charge of all the financials and administrative processes that we have in the company. As we are incorporated in the US, but have practically two companies in Mexico that are connected, and there's some work in the transition and business models between the companies, which in the end is the one that we want to replicate in other countries as well. So that's why we're creating this scheme in a way that can be replicated in other countries easily. And myself, who I practically do a little bit of everything, but I mainly concentrate in the relation with the refineries abroad, which are, let's say, the main clients that we will also continue to collaborate with, even if we are already outside of Mexico, and with investors, which is practically the fundraising activities that we have in our team, setting up practically the right challenges or goals that we have in each part of the company.
And how the three of you met initially? What was the origin story behind the team?
Well, Max, I met in Colegio Alemán. His family was in Mexico for work, and he did his abitur, which is practically like the last 2 years of preparatoria in Mexico City. And that's practically where we met. We were both in the physics course, license course. So that we spent a little bit more of time together and getting to know each other. And we have practically been friends since then. At some point, like 8 years ago, I had the first idea of working with electronic waste. And I talked about it with him, and he saw the margins, saw the market. And so I identified that it was a good opportunity to work on. At that point, I decided to do something else. So we didn't start working together there. And as we did the consultancy project, as I finished the consultancy project and decided to start a company based on that, I talked to him again and invited him to join the team. And Erube, I practically met through the consultancy project. He had a company that was doing practically electronic waste or focusing on that area, but more at a low level. And after the project ended, we also discussed about the possibility of joining forces and trying to do something more integral to practically bring together our different capacities in order to create a larger company.
And in addition to the three of you, how big is the team? And who's doing what? Or what are some of the key skills that you have inside NIU NIU?
At the moment, let's say the core team is 7 people. We have 3 engineers, female engineers from Politécnico Nacional and IPN, that have been already for a while working with us, 2 of them. And one of them is practically the relation towards clients, also civil society, and she conduces practically the whole journey of relation with any kind of e-waste supplier. At the moment, she's directing practically the project with the Universidad de Guadalajara, which will impact, we hope, 25,000 students this time. Last year, it was 11,000. And we have another person who is practically putting the business model in place. She's an environmental engineer and is taking care of the KPIs at the production side, as well as, let's say, the relations with investors and the refineries. And we have also someone who is taking care of practically all the administrative aspects related to the 3 companies. There's also someone in the AI team who is practically the AI lead, and that's practically it, I think.
So we talked about the team. You're basically covering all the bases for the type of startup business model that you guys have. But now please walk us through the main priorities that you have for the next 12 months, for this year. What are some of the key things that you're focused on, especially in terms of clients, in terms of partners, investors?
We have 3 main goals. One is proof that we can execute with excellence the transboundary movement of hazardous materials, which is something which is not that trivial, and which is practically the channel that allows for the marketplace to exist. The second one is to prove that we can access the amounts of electronic waste that we are projecting. And we believe that this is possible given the margin that we get with particularly refineries abroad, and that we partly transfer to the local players, which creates a natural funnel towards us. And third one is to prove that the profitability of the business is the one that we have on paper, right? We have now the costs related to acquiring and transporting, the whole logistics related to the export of these materials. And we also know what are the prices that are being paid abroad. But to do it, let's say, at the large scale, could even make the profit larger.
And especially when you mentioned about proving access to e-waste, so I would assume that large e-waste producers or collectors, those are the type of organizations that are probably key to partner with or to establish some type of collaboration so that you can have a continuous stream of e-waste that you guys can then connect with the refiners. So what are some of the profiles of these organizations that would be interesting for you guys to partner with, to establish connections with?
Mainly the OEMs, Tier 1, Tier 2, component manufacturers from industries in the automotive sector, in the aerospace sector, as well as the IT sector. They are the ones that generate the largest amounts of e-waste and with whom we would be really interested to partner with.
And in terms of refineries, are you looking for a specific type of or specific profile of refineries that you would then be sending these e-waste towards?
Let's say the amount of companies that refine, it's not that large. There's not so many companies, and I think we are most already in contact with most of them. That part is practically covered. Probably, the relation to investors would be also interesting. We are currently raising a $1.5 million US round. We have some investors already in our cap table. I mean, institutional investors, VCs, and we hope to close the round before the end of Q2. So that is where we are at the moment in terms of fundraising.
And you were also mentioning about schools where you're generating this awareness, the connection with civil society. What are the type of organizations that are interesting for you to create that awareness? Also, I would assume in terms of access to e-waste, that's also a significant source. Could you elaborate a little bit of the type of profile of organizations that are also interesting for you?
I mean, at the moment, it has a regional scope, mainly for Mexico City, Estado de Mexico, and Jalisco. That's where we can ensure that we can implement these programs in a proper manner.
Because of the geographical proximity to the plants that you guys have.
Exactly, yes. It is practically high schools or universities that have more than 1,000 students and that would be willing to implement these environmental education programs with a large amount of their students, because it doesn't make sense to like create an environmental education program for 50 students, right? To the collection, that becomes very inefficient, and in the end it's not solving the problem.
So the amount of student is a significant KPI. So you're tackling like large schools, large universities, that their students are generating a significant amount of e-waste, and that could be also an interesting source. Plus, of course, all of these awareness that you were mentioning.
I think the amount of students, 1,000, is not that large. I think there are many institutions that have that amount of students. The problem is the amount of students that they want to do the project with, right? Like if they have, for example, 5,000 students, but they only want to do it with 100, then it doesn't make sense. It has to be an amount of students that really creates a volume that it's required and critical practically to also cover the logistics costs, etc.
So, Dylan, it's fascinating, all the things that you guys are doing. But since we're reaching the end of our conversation, I would just like to ask you again for your advice for other inspiring founders. You already gave a great advice in your previous interview, but I would also like to just ask you again in terms of what is your key advice, your key recommendation for our listeners that are looking to build a company like yours, fast-growing company. I think it's a big challenge that what you guys are tackling. You're connecting the different players, developing own technology. So I think it's fascinating what you guys are building. So what would be that advice that you would give for somebody that is starting and looking to create something like this?
Thank you very much for the encouraging words and for the invitation, Sergio. I think, related to what I said last time, to be perseverant is also to find what motivates you to do this. And I wouldn't recommend it to be, the financial aspect of it in the beginning or purely, because in a startup, building a startup, there's not always, this idea of a bunch of money, like in your table to do whatever you want. So for that reason, I don't think it's the best motivation strategy that you will have long term, because this is it's more like a marathon playing than running than 100 meters. So find the motivation that will really keep you up at night and will motivate you to wake up, even on Saturdays or Sundays when you have to work, which is beyond the financial motivation.
Dylan, thank you very much for taking the time. We're going to be, of course, looking forward to the next big evolution of NIU NIU. And thank you for being here again.
Thank you. Bye-bye.
Bye-bye. And thanks to you for joining us today. Please remember to subscribe via your favorite podcast app to be notified about new episodes and share with us your feedback. We would love to hear from you. Thank you also to the Maxpreneurs team, Valeria Morel, Hector Barragan from Hyper Voltage, Francisco Jaimes, Pamela Elizalde, Katia Cruz, Rocío Marroquín. I am Sergio Chavez. See you next time.